Hello, this is Anthony Manning, and this is for the Physics Final, question 5. This question was about a ballistic pendulum that is going to be shot with a piece of gum that sticks to it and then raises its total height by 5 centimeters. In order to solve this, I initially started with kinetic and potential energy to solve for the velocity that is within both the gum and the ballistic pendulum itself. And then from that velocity, since I already know the masses given by the question, I can then solve for the momentum. So in order to do this, we first started with this relationship of the potential energy is mass times gravity times height, with kinetic energy being 1/2 mass times velocity squared. And this, when you set this up, because especially since the ballistic pendulum initially started at 0, like there was no initial movement. So when factoring all of this out, I'm going to start, adding in the masses, and then I'm going to start solving down for the velocity, eventually taking the square root and plugging in all the numbers. And I ended up with the velocity of both of these was, just say 1 meters per second squared, 1 meter per second. From there, I can plug that into the momentum formula with both of the masses, and I get 0.15 kilograms per meters per second. And for the last part, it's pretty much like a logic statement. It's an idea that when you were asking a question of what was the initial speed of the gum right before it impacted, and since the initial mass, or the initial velocity of this was 0 and it's mass times velocity for momentum, that means that the initial momentum is going to be equal to the final momentum in this system. So when solving this, since this was the momentum that was solved for both, we could just divide the mass by that, and that gives us this initial velocity. And since it's a small piece of gum, it makes sense that it didn't move it too much. And I got 25.6 meters per second for the initial velocity of the gum. Thank you.